We're going to go live about a minute in advance. Let's get going. All right, welcome back. We are Game 2014 in the fall 2021 semester, and it's Mobile Game Dev 1 at George Brown, and it's week 6, part 3 of our broadcast. Again, this is bonus content happening in the second section, and it's after the first section. We've kind of done everything that we did in the first section pretty quickly, and now we're going to think about optimizations. So let's think about our problem. We had our problem. And the problem I posed to everybody was, how do you fix this? This is pretty ugly, right? I mean, we said that as an example, a couple of scripts here that we have are pretty ugly. First, I kind of organized these inside of another folder. We can add a folder here for organization. I'll call it bullet scripts. So all the related scripts, I kind of put them together. So all of this, let's put them in there. Bullet scripts, right? And we can put other folders in place as well. I like to organize it this way because then I can see all the bullet stuff in one place and I can organize myself accordingly, right? One thing we really had a problem with, the BulletFactory looked pretty good. Like right now, the BulletFactory just looks like this. It's not really using the bullet pattern, okay? So one thing we can do is think about how to use the factory design pattern. And remember that the factory looks like is something that looks like this, where we have some sort of abstract class, and then we have a couple of concrete classes down here. The actual structure, we also have a couple of concrete products we're going to create, right? So we have a bullet product, the bullet class interface, if you will, and each bullet interface has a couple of different implementations, the truck and the ship, if we're going to make a bullet interface. So those things that we have, we've kind of put those two things in place. First, we make an abstract superclass, then we do one of these, and then finally we have the structure that we want to use that includes all that stuff, right? That is going to further give us an abstraction, but closer to the design pattern we want. So where to begin? Let's think about bullets. So how do we do an interface, and what do bullets do, right? If I was going to create a product, enemy bullet, or a different kind of bullet that we have, right? Let's say, for example, a player bullet or whatever kind of bullet. Do I need to make this interface in Unity? That's the question, because you have two concrete products. In many cases, we've already handled this stuff here with the prefabs. Could I do different scripts that are, we use an interface? But what interface would be similar, right, from one bullet type to the other, but deliver something else, a different form of behavior? Well, let's take a look at the bullet behavior then. That's the first step. That's where I would look first. So if I looked at the bullet behavior, we can see that we have a bullet type. Theoretically, this bullet type can disappear, right? So we can save some code just by saying, well, we don't care about the bullet type anymore because we're making a new bullet, right, from bullet behavior, where bullet behavior is actually something that's going to be abstract, right? Our bullet behavior script. And we're going to have two types of bullet behaviors. We're going to have a bullet behavior that is of type player bullet behavior, and enemy bullet behavior. All right, so we're going to actually make two different things. How about the speed and the direction and all that kind of stuff? Well, this is where we can optimize this kind of stuff before we make a subclass. But let's keep going. So CheckBounds is something that we can change, right? Because the bullet checks the boundary of where it's at, and it's going to be different according to different bullets. Not all bullets. If I have this instance as an example for my player bullet, chances are I'm not going to check the boundaries for my player bullet the same way. Also, one thing we can also think about is some of the configuration details we've put here. For example, does the superclass bullet need to know its direction? That's more of a subclass thing, right? The superclass bullet doesn't need to know that. And same thing for bounds and a bunch of stuff. So what does it need to know, right? It needs to know its speed, its velocity. So the bullet's always going to have a velocity. Maybe even, it could have it could even have a direction, a velocity and a direction. But bounds, that's kind of something that, you want the player potentially to fire in different directions. I want to fire to the right or to the left or up and down. And so we have to separate where this kind of stuff works. So right now we're using bullet direction up, right, down, and left. But could we not optimize the bullet so that instead of using a switch case, it kind of uses some other method? So what do you recommend? How can we simplify the direction? Because here in the start method, we're using a switch case to kind of indicate which direction the bullet's going to go. Is there a way of simplification? Well, earlier today in our first section, Maxim recommended, one of our other students recommended a vector, right? A vector 3 for our bullet velocity. We're kind of doing it already, right? We have a kind of a velocity right here with the speed, right? That's something we've got going on here. The velocity itself is really based on the direction. Do we really need a direction if we have a velocity? The direction is literally just a pull down, just to let us know, kind of a friendly pull down of selecting the velocity. That's all it does right now for us, right? So yes, we could, but we would kill all this code, this whole branch, right? We would kill the branch if we just simply used a vector and not even had a speed, right? So speed and the bullet velocity, we can keep the bullet velocity. That would be up here, right, where the speed is. And the speed we just put inside the proper place for the bullet. We could do that, all right? Where the speed is something we just modify, and we can have a velocity, like an actual magnitude and direction of a vector, what the velocity is of the bullet. And we can update that on a regular basis. But if that's true, right, then we could use a rigid body, right? We could do that too if we wanted to in the future. For now, we could get rid of the direction. Let's just comment it out. And I want to recommend this to see how much code we can save, right? We got rid of the direction. And now if we got rid of the direction, we don't need bullet direction up, down, right, whatever. We can literally just have our vector 3, kind of public. All right. And the bullet velocity is something we can put up near the speed. There it is. And now for the speed, we'll just undo that speed. Okay. And then guess what? All of this is gone. So we can comment all this out. So the bullet velocity itself is what we have to configure. And that's going to happen again. We can definitely configure it inside of the sub bullet type, right? But for now, let's make it work as is, but by optimizing first. Let's optimize first. Okay, so again, we're going back to the actual bullet prefab. So now under enemy bullet, we no longer have a bullet velocity. It says use range with float or int, and it kind of killed that. So that's what I can't do here. So let's make sure that the range, right, for this is it can't be used for velocity. So let's kill the range, right? And speed is gone. Actually, let's undo. Let's just comment it up. So we can always come back, and if we think it's better the other way, we can always go back. But so far we've killed a few lines of code, huh? And let's see if it works the same way. So going back, and let's see how it works. We got our bullet velocity now, and we can say that the enemy bullet, well, the velocity on the y-axis is a negative 0.1. I mean, that's simple as what we can do. We can do that. And the same thing goes with the player bullet. So player bullet, we can say that the velocity is 1.0. right? So, or sorry, 0.1. Okay, 0.1, negative 0.1, and that's the difference, player and enemy. All right, so since we don't need the direction, then, well, we can get rid of it, right? So we can go back to our bullet scripts and we can look at bullet direction and just get rid of that whole thing. Delete. No more bullet direction. Okay, cool. So no more bullet direction. We don't need that anymore. That was the only thing I used it for. So let's get rid of all this and all this and all of this, right? Because we can still do everything we did down here, except we don't need to use all that stuff. So that's a bit of a lighter script right there. And we actually got rid of one whole script altogether, but let's see if it can still work the same way. So again, just little optimizations at a time. And run. Still be able to fire bullets, and this should still go in the same direction, no problem, without that script at all. So this is similar to what Maxima told us earlier. Works for me, okay? Now, let's think about matching the pattern. Do I want to create an interface, right? And what will the interface do for us? What will the additional interface give us, right? I mean, it's going to give us the ability for us to describe what type of bullet it is. I'm kind of accomplishing that with BulletType. So BulletType, right now, we can kind of get rid of it eventually, right? We don't need a BulletType. BulletType right now we're doing because we don't have another way of describing the type of bullet that we have. All right, so what can we get rid of? Because remember that a bullet, if I'm going to have something that, are all bullets going to have velocity? That's the way to start. And the answer is yes, they're all going to have velocity. Is each bullet going to have some kind of boundary, bullet bounds? Yes, for sure. But maybe there's another way of doing the bullet bound thing in the first place. But still, everyone's going to have that. Are all bullets going to need to reference the BulletManager? Yes, all bullets are going to have to reference the BulletManager. Okay, all right. So that is interesting, right? I need to make a reference to the BulletManager itself. Is there a way for us to cut down on this stuff altogether? And again, I'm being, kind of straight up with you guys when I say this, right? But I want to think about a way that we can think about the BulletManager itself and how to optimize further, right? How to optimize further. So what can we do here? What can I do so that I don't have to always make this reference, right, to the BulletManager? Well, we can think about it actually as there's only going to be one BulletManager. And when I think about only one of something, then I'm thinking about singletons. I'm thinking about singletons first before I move anything else out of here, right? Because then I don't have to reference the BulletManager and I can cut down on the start script altogether, which I don't need. If I cut down the start script and the BulletManager reference, then how do I do this part? BulletManager return bullet. Well, there's only one, so then I can have some kind of instance is what I really want to do, right? An instance. So when can I get that done? How does that work, right? And guys, and I'm posing these questions to you so you can think about it for yourselves. How do I create this stuff? As an example, how do I make a bullet manager, right? And what's the difference between a bullet manager and some kind of something that I'm using here that I'm referencing compared to something else? Well, let's think about what a singleton would look like in the BulletManager itself. So let's go back to, and we'll kind of cover this again later. I'm going to revisit the singleton later on this semester and how to do it in Unity, but let's do it now. So I'm going to go to BulletManager, and under the BulletManager, I want to think about what I need. So let's start commenting here. Let's start commenting. And I'm going to say something that looks like this. I'm going to say step 1 I really want to say I want to create, remember how a singleton works? I want to create a private static instance. All right, that's what I want to do, a private static instance of the BulletManager itself. So I can say private, and I'll make it a static. We'll call this BulletManager. Okay, and I'll call it instance. We'll call it instance, and we'll set it to null, just like what we've done before inside of our C++ code, right? So private static instance, it's null. And step 2, all right? I want to make our default constructor private. Okay? And if I do that, it's going to look like something like this, private BulletManager. Okay? So I want to make our default constructor private. So you can't instantiate an object of type BulletManager because it's private. Okay? Not by default anyway. In this case, what I'm going to do is I'm going to remove BulletManager from MonoBehavior. So it's not going to be of type MonoBehavior anymore, right? And because we've made it not MonoBehavior, then inside of the game controller, I cannot include BulletManager as a script on MonoBehavior. On game controller. Okay, just pointing this out. Because BulletManager is not of type MonoBehavior, I can't attach it to game controller. Let's remove it. It's still going to be there, but it's going to be something that exists on its own. I don't have to track, BulletManager here. I can still make game controller its parent, transform parent. I'm going to have to make references to something else in a bit. Okay, one thing at a time. Next. So if this is true, right, and it's not MonoBehavior anymore, right, then next step, so step 3, I need to make a public static creational method, right, for the class, right, for class access, let's say. Okay? And that means it's some kind of, think about it as a portal or an interface. We usually call it instance with a capital I. So public static, and we're going to say it's called BulletManager. And we're going to call this instance. So the return type is a BulletManager type, but instance is going to be what it's going to be called. Okay? Instance must return a type of BulletManager, and the way this looks is if instance is equal to null, right? Then I want to say that I want to instantiate a new object of type BulletManager. Guys, it's almost the exact same code from C++. And then I want to return instance. Okay? So this is our instance. We're going to say BulletManager.instance. And then create factory as an example. Okay? Next, let's think about the next piece. So now that we made it an instance, right, we have our queue, which is okay, enemy bullet pool and player bullet pool and all that kind of stuff. And right, what we need is some kind of, remember, we're not going to have a bullet pool that's built, right, or maximum bullets. So we need a way of instantiating our BulletManager for the first time. The other thing is that, what about that factory, right? Well, if we make our BulletManager if you think about this, right? If we make our BulletManager a singleton, that's awesome. But then how do I get reference to the factory? I can't, right? I can't use getComponent. getComponent is if you think about what this is a MonoBehavior type. Okay? So The only way I can do that is if I make this of type MonoBehavior again, right? If I did this, then I can use getComponent, or I can try and be more specific, and let's do it explicitly, where I want to include Unity Engine, and I want to go down to where it says getComponent, and then start like something like this. Hey, MonoBehavior dot getComponent. And, well, kind of doesn't work, right? It says cannot access non-static member getComponent in static context, right? MonoBehavior.getComponent, that's nice. BulletFactory. What I want to mean is I want to, instead of getComponent, I want to find game object, find of type BulletFactory, something that includes the BulletFactory, which is my game controller right now, right? So let's do that instead. So we'll say, hey, MonoBehavior, I want to, let's see if I can use this game object. Hey, game object dot, I want to find object of type, and this is a way of doing it, BulletFactory, right? And I want to save this inside of the factory, right? So I don't have to use MonoBehavior up here. I don't want to do that, okay? But I'm going to search for an object in the hierarchy with BulletFactory that has BulletFactory attached to it. That's what this says. Now it says that access to a static member of type via a derived type. It says name can be simplified. I'm leaving that in there for now. Okay. So far, so good. No other changes that have to be made because we're good to go. I don't need to make them public and static. Everything else is the same, right? But I do need to specify type for the bullet. So this is the first optimization. The first optimization is making my BulletManager a singleton. All right. And those are the pieces that I need. So kind of 1, 2, 3 step. Clear? How do I use this thing again? Well, let's go back to enemy behavior. Enemy behavior can't do this anymore. So I can get rid of the references to BulletManager. Hey, goodbye, BulletManager. I don't need this reference anymore. And here is where we make the first change. So I'm going to say something like, hey, BulletManager, capital B. Hey, BulletManager, instance. Dot, get bullet, right? That's what I want. That's my new structure. And we've seen this structure before in C++. Okay. We also have to fix other scripts. Player behavior. We did the same thing in the player behavior as well. So we don't need a reference to BulletManager anymore, right? But down in here, we can say that, hey, BulletManager dot instance dot get bullet. Okay, same idea. And let's make sure that enemy behavior is done right too. Yes, it is. So that's how we access the BulletManager now. Cool. How about BulletBehavior? Hey, BulletBehavior. We need to access the BulletManager. So let's comment this out and this out. And same thing happens before. We're going to say that, hey, BulletManager, and then instance dot return bullet. And let's just copy paste. Okay. So far, so good. So far, so good. But does it work? So BulletManager, okay. BulletFactory, is there any side effects on BulletFactory? So far, no. Enemy behavior, so far, no. Player behavior, so far, no. All right. And what else? Let's take a look at other things because we have to make sure that they're all good to go as well. Let's just re-inspect and let's run it and see if this thing actually works. Oh man, it says objects not sent to a reference to an object, get bullet, and we're trying to make it go, but what happened? right? It says, hey, I want to do bullet spawn position, but this part right here, right, in our enemy behavior, crapped out. Why? Well, let's go to definition for instance. So instance, again, if the instance is null, right? We said the instance is null up here, private static BulletManager instance. We did that, right? So what happened? Did we ever get to this point? Let's see that. So again, we'll go to debug.log. So we'll say new instance. All right. Well, actually, we're not a new instance here. At this point, we entered instance. Okay. So we got to this point. Let's see if that's true. And we're going to clear this up and press play. Hey, we entered instance. Just as about to fire, we had this null reference error that went here, right? But we entered instance, which means we're inside of our BulletManager and we came to this point. Okay, now, what about in here? Did it detect us in here? Let's do this. Because we want to make a new BulletManager, yeah? And that's the instance that we want to share. So now, creating new instance. Creating new instance. Remember, public static, private static. So private static instance we set to null, but now did it detect it? This is like one of the keys to making this work. Okay. Without this, none of it matters. All right, keep tracking. Let's try it again. And creating new instance. Yay, look at that. That takes us right where it is. But somehow it says in our call stack, right? Here it is. Take a look at this. So we execute the player loop. We fixed behavior manager update. We did this, and we come into this point right here where we say, enemy behavior fixed update. Look at that. So enemy behavior calls BulletManager instance. We do a log, and we do another log. And then, where does it go next? This is our call stack, right? So here's our debug string to file. And somewhere after this point, it has an issue. Okay, so here we've made a BulletManager. We've done it, right? But guys, BulletManager, it did a couple things here that are wrong, right? Remember that even though we did this, start doesn't belong. It no longer belongs to the method, right? So start is a method that is Unity based, but it's for MonoBehavior, right? And there is no start. We never did this part or this part. We never did these things. And that's why we get this issue, right? Yeah, Herman said it too. So one thing is, just to keep it separate, let's rename start and we'll call it to initialize. Okay. I recommend something like initialize or init. Let's also make it so it's private so we know what it is. And we're going to call initialize inside of our BulletManager constructor, right? Oops. Right, we need to call initialize after BulletManager has been created. We could put all of this inside of BulletManager constructor as well. This is the constructor, right? But I'd rather keep it separate because maybe you want to put more than one thing in the constructor. Also, I don't want to call it start because start is like, it's based on MonoBehavior. We're not really doing MonoBehavior in this one. So this is definitely what we need to do. Without this, none of it's going to trigger. So now we know we've done these two things. So this worked actually. We came here, we detected there was no instance. we created a new instance, and then when we tried to do a get bullet, we couldn't do the get bullet because the bullet pool didn't exist. And that's what the problem was. Okay, let's try it now. So save, go back, and let's run it again. So let's clear this and run. Cool. Hey, we're getting bullets. And it even found the game controller, right? Even though it had nothing to do with anything. Right? It's not even part of it, right? We kept the Unity engine there, so that way you can find bullets and it's good to go. That means you should probably be able to fire bullets too, right? And this works like it did before. So we saved ourselves a couple of lines of code, and we made our BulletManager a singleton. Okay, that's what we did. So let's call this like this. We'll say singleton. Okay, so we specify that. So that's the first thing. Let's put this up on GitHub. That's the first optimization. We only want to have one BulletManager, right? And we can make it a singleton. All right, could we have done it a different way? Yes, we could still do more stuff here, and we will, but one step at a time. The other thing we can do is probably do the same thing to our factory. There should be only one BulletFactory at the end of the day, right? So you could probably do a BulletFactory singleton as well, okay? But what it does is it does a couple things. One, we hide our code. We can make our code work from anywhere. We don't have to attach it to a game object, which is way better this way in many ways than doing it. There are some dangers here. There are some problems, right, for sure. You know, and we'll talk about them in a second. For example, now we can make a reference to the BulletFactory for sure, right? But now the BulletFactory is going to have some challenges too. So first things first, let's think about this. Save, and let's go to put everything up. Comments around this. What do you think of this one? This little optimization. Save project, save scene, and exit. What are your thoughts?
I'll try to answer anything, but I'm generally best with factual questions.
I wasn't asking you. We had another visitor answering. Our automated visitor from Amazon. All right, so let's stage all changes here, and we'll say converted BulletManager to singleton. There's some problems with this approach as well, by the way. All right, there are some problems, but we'll talk about it in a bit. All right, cool. So we converted it, and we're going to push it up. Any thoughts, guys? All right, so now that we've done this, and let's bring up, let's go back up and bring that up again. Again, this is not required for your lab. This is bonus content. So the other stuff that I showed you earlier is enough, right, to get you going. But this structure is interesting. If we can do the same thing with our factory, right, which is neat. If we can do the same thing with our factory, that'd be awesome. But how the heck do we get our prefabs from our factory? Because remember that if you follow along, yeah, it's okay. If we kind of go into our structure here, right? We have our prefabs folder, yeah? And this is great. But our game controller, which has our BulletFactory connected to it, we get our prefabs automatically by dragging and dropping. Wow, this is an issue, right? Because we can't get a prefab by dragging and dropping anymore if it's not MonoBehavior. If I make a class, as an example, and that class is a singleton, and it's not MonoBehavior anymore, I don't have a start function or whatever anymore, right? Then it also cannot be attached here to an object, to a game controller. I could still make it a MonoBehavior class, but then it's not truly a singleton. And the reason why it's not truly a singleton is some stuff happens in the background with Unity where Unity calls the constructor function. And whether you like it or not, it constructs the object. And so it's not truly a singleton. So a little bit more overhead is what happens. Okay, just FYI. So BulletFactory, nice idea, but we have to overcome that thing. For now, let's just remove it as a component because we know we're going to come back and the BulletFactory is going to become a singleton. How does this look? Well, it's like what we did before. Okay, so we're going to start off and we're going to say that the BulletFactory is now going to be a singleton. Let's do this. So we're going to make it a singleton. How do we do that again? Remember that there's some stuff that we don't need. For example, bullet types for enemy bullet and player bullet. For now, these are going to be more like prefab references. So prefab references. Okay, that's where we're going to store them in there. At the beginning, we still want to make, before any of this stuff, step one, let's make a private static instance. And what we want to do here is we want to make this private static. We want to call it an instance of BulletFactory. And we're going to call this instance. That's the first thing. So we're going to make that first. And what we want is we need to make so we want a game controller. We want to still have access to the game controller because that's where we want our bullets to come to kind of connect to. And we really don't have that yet because we've kind of said that it's going to be connected to our transform. Temp bullet transform parent is equal to transform. But remember, our BulletFactory is no longer going to be a type of MonoBehavior. So we can't instantiate the same way we're doing it here or use the transform if BulletFactory stops becoming MonoBehavior, right? So we need some kind of game controller reference because that's where the bullets are going to be, right? So let's make it private, again, game controller, and we'll call it game controller. Okay. Next, step two to the whole prefab or the singleton process. Make the constructor private, like we said before. So we're going to say private BulletFactory, and our private BulletFactory is going to call a private initialize function. So we're going to have an initialize function. And which is going to return void, private void initialize. And this is where our initialization is going to go. So here we're going to call initialize, right? Just like we did before. And inside of my initialize function, I want to do a couple of things, okay? So I need to access my prefabs. So access or make references, create references to prefabs here. I'm just kind of commenting because this is what I want to do, and I haven't done it yet. Okay, so that's the step two. Step three, let's go into step three. All right, just to make sure we're following along. Make a public static creational method, right, for class access, which is our instance. Again, you can call it get instance or whatever. I like just calling it instance, public static, and it's going to return a BulletFactory type, and then we're going to call this instance. And just like before, if instance lowercase is equal to null, then I want to set instance to a new object of type BulletFactory. Otherwise, just return instance. Okay, so that is step 3. So we want to do a couple things. We want to create some references, but the only way that we can do this properly, I'm just going to be honest with you guys and tell you, is we want to move our prefabs into a resources folder. Okay, into a resources folder. So all the prefabs that I want to have access to programmatically, I've got to be in a resources folder. Right, so inside of our Unity, we got some errors here. I'm not worried. We're going to fix them. I'm going to go into a new folder. So I'll create a new folder, and we'll call this the resources folder. Inside of resources folder, we're going to make a new prefabs folder. And what I want to do is the prefabs we want to move into our resources folder, I'm going to drag and drop, which is going to be the enemy bullet and the player bullet. So again, resources, prefabs. Okay, the rest we can keep up here because we're not loading them dynamically. All right, cool. Back to this. So now that we've moved our folders in there, and I guess we should probably say, let's put some steps in here. So again, we'll say step 4, create a resources folder. Right? And then move our prefabs, step 5, which is kind of what we did. Move our bullet prefabs into the resources / prefabs folder. All right, so kind of a 2-step process. We made a prefabs folder that was in there, and moved them in there, okay? Okay, and then from there, what I want to do is let the create references to prefabs. How do I do that? So that is what I want to do. I want to say that enemy bullet, right, is equal to, and this is the new thing, resources dot load, right? And I want to load what from where? My prefabs / and I want to say the enemy bullet. It's got to be exactly the right name. So inside of my prefabs folder, enemy bullet's got to be spelled exactly that way. And I want to cast this as a game object. Okay, so that's the first thing. So that's what I want to do. So resources load, and then enemy bullet is cast as a game object. I want to do the same thing for player bullet. Player bullet is equal to resources dot load, and I want to go into the prefabs folder and player bullet, and I want to cast this as a game object. Okay, so that's getting references to our prefabs. I also want to say that game controller is equal to game object dot find object of type, and then game controller itself, because that's going to find a reference to the game controller, so we can add in the game controller is going to be the place where I want to set up my transforms. Okay. All right. So that's the initialize function. So initialize function gets called from a BulletFactory when the BulletFactory gets instantiated, and then we're going to make references to all these things. Now, let's continue with our errors. Instantiate. I love instantiate, but we can't use instantiate by itself anymore. We need to use this MonoBehavior dot instantiate. MonoBehavior dot instantiate works, right? But we're being very explicit here, as opposed to just using instantiate itself. So I can say instantiate the enemy bullet or the player bullet, but I'm calling MonoBehavior directly. And then what we want to do is this last piece, which is temp bullet transform.parent is equal to, we can't go transform anymore. We need to change this to hey game controller dot, we can't use transform, it's game object dot transform that we want to say. And that kind of says that I want that the parent transform of the bullet be the game controller's game object's transform. Very specific. And now this is the new BulletFactory. So no drag and drop. It is using the BulletFactory, and now we need to fix the rest of it because now we've messed things up, right? We have an instance to access the BulletFactory, and the BulletFactory is going to be accessed by the BulletManager. Let's go back to the BulletManager now. So we're going, hey, look at this. I want the factory to be accessed by the BulletFactory. You don't need this anymore. Goodbye, BulletFactory. And goodbye reference to this BulletFactory. So now instead of the temp bullet saying, hey, factory, create bullet, that's not going to look like that. It's actually going to look like, making some space, hey, BulletFactory dot instance dot create bullet. And that's going to do almost the exact same thing. All right, so no more BulletFactory and no more BulletManager. They're both singletons. Do we have to change anything in BulletBehavior? Well, no, it's been changed already. So we're okay here, right? But we can start getting rid of some of this code. So we don't need this anymore. And if we don't need this, we don't need start anymore. We can get rid of the start function altogether. So BulletBehavior, don't need start, don't need this thing anymore altogether, right? And this is good. This is looking better. This is looking a little better, a little better, a little better, right? Enemy behavior, again, we can go up here and take a look. I don't need the BulletManager anymore, right? BulletManager is gone. I don't need this anymore. And you know what? I don't need these lines of code anymore. So I've saved a few lines of code. Again, maybe that's not the optimization you're looking for, but this is where I would probably go first. And after I got this, then I can start thinking about interfaces and what I can do even from here. Okay. Now, positives and negatives about using singletons. Positive is it's one-stop shop. Negative is it does two things at once, which breaks the single responsibility principle. All right. So let's run and see what happens. Let's see if this fixes our issues, right? And does it even run? Does it even work? Because even though it doesn't show errors, the proof is actually in the test, right? So do we actually test it out? Can it work? Can I still get the same functionality that I had before? And we're pretty good, right? Look at that. And all of this is coming from a factory that is a singleton, and our prefabs, our resources prefabs are the enemy bullet and the player bullet. We can have a separate prefabs folder for the enemy and all the other stuff, right, that are not going to be loaded dynamically. Okay, this is a great place to put it up on GitHub. So now we've added our factory, made our factory a singleton. So file, save project, and we'll talk about singletons again as we move forward. So again, we have all these changes, and we'll stage all those changes, and we'll say converted BulletFactory to singleton. And then push. Comments. What are your comments? Yes? Good? Bad? What do you think? It gives you a couple of other ways of accessing the code. That's the first thing. All right. Advantages of what we just did. We've saved ourselves a pile of code already, right? But there's still optimizations we can make. And the next optimization is the the BulletManager right now has, kind of a couple of different queues, right? And I liked Herman's suggestion, which is what would happen if you change scenes? Wouldn't matter. Wouldn't matter. Singletons are singletons are singletons. However, one thing that we would have to have in the scene is we'd have to have a game controller, because the game controller's got to be found. Otherwise, the transform won't point to anything. So you always have to have a game controller on the scene. Okay. And then as long as you have a player prefab and everything else, no problem, because you don't need it to attach to anything anymore. Notice that it's freed up, right? So they're universal now. The BulletManager and the BulletFactory are there if you want to use them or not. Yes, yeah, but you'd have a new game controller. That new game controller is going to be whatever. Because remember, every scene is going to have its own controller, its own world. Now, you could make a game controller that's also a singleton, but that's just going crazy. Right? We don't make two singletons. If you overuse singletons, it's just as bad as anything else. A BulletManager, there can only be one, right? So this is where you would use a BulletManager singleton. One thing to note is, what about if I inherit from a BulletManager singleton? As an example, what happens? To my, to the stuff that's happening, right? So I could use a generic, where I can make a generic type of, which is like a template class. I could use like a generic, and the generic itself could be of type. I could say there's different types of BulletManager, and what I could do is in the generic, I can make a class, a BulletManager singleton, that's of type, enemy bullet, and of type player bullet. I could do that. I guess that's another thing we could do. But let's do what Herman suggested, which is, hey, I've got these two queues, and what about if I made an array of queues? Can I do that? Or could I do something else? Another structure that I can use. Can I even do that stuff? A list of queues, if you will. Might be better, right? So remember that we can do a bunch of different things. Collections, if I say a new list, a list of type, what kind of generic type am I going to make? Remember, angle brackets mean type. A list of type queue objects, right? Queue game objects, right? If I did this, so a list of type queue game objects, and I called them, bullet pools. Okay, that's what you're talking about, Herman, right? A list of type queue game objects, not an array, but a list, because it's easier, right? It's a bit of a bigger structure. It would work well with the BulletType enum. Yeah, this is okay. I could still do it this way as well, but what the heck am I going to do here? So the question is, BulletManager, we use the player, a public int for enemy bullet number and player bullet number, and that really was just us trying to get a view into the player. Now these things are useless because we're never going to see these things ever. And these are public always, but kind of useless as well. Let's comment these things out. But how does this work? Well, I need to initialize. Let's just do this for a second. We're retrofitting, right? Remember? So, or refactoring, as like what I like to say. So here is, we want to make, hey, bullet pools. I want to make a new list of type Q game objects. That's nice. But, how many of these do I need, right? Because remember that inside of the list, you have a list of type Q game objects. So 2 Qs, as an example, or 3 Qs or 5 Qs. But they're not automatically created, right? So even though I did this, I have to specify how many types there are. So if you want to be that can be tricky. We can do some tricky stuff here to make us go. Well, I'll come back to this in a second. So let me just put a note. That's a to-do. need to instantiate new queues, queue collections. Because if we don't do the queue collections inside of the list object, and how would you dereference these things as well? That's something else that we'd have to think about, right? Number of queues, number of type bullet. I love it. Yes, that's the way I would do it. But let's go down to this. So enemy bullet pool wouldn't be a thing. On queue, we'd want to try and do something like, instead of a switch case, depending on the bullet type, the bullet type would be 0. And so we would say something like this. This new code would be looking like, and I like it. I love it, Herman. It would be like almost like bullet pools. And I would look at the bullet type. So bullet type enemy, or the type, let's just say, call it type. But the problem with the type is, and I'll say dot on queue, and then temp bullets. That's what you want to do, right? This is what you want to do. Bullet type, bullet pools type, and then on queue that, and then the temp bullet. We don't care about this anymore because we don't care about keeping track. So these can go. All right, so far so good. And type has to be converted to an int, unfortunately, because that is typically an enum, but now we're converting it back to an int. This is how the way it works. Okay, so this is what you're looking for, right? Correct? Okay, I love it. This is nice. We can get rid of all this. I'm being bold, so I'm deleting. I'm deleting all this stuff because we don't need this anymore. But we need something to instantiate those things. So far I'm cutting down on all these queues and everything else to make it a little sleeker. How about all this? Switch case. Well, it's the same thing, right? We don't need to do a switch case anymore. We can say that if our bullet type, whatever the bullet type that we're looking for, game object bullet type, if that bullet type is the count is less than 1, then we want to add a bullet type of that type. Boop, right? So let's get rid of the switch case, and let's get rid of this part. And we only need one of these, right? So going back to this, and we don't care about enemy anymore because we want to say bullet pools count. So bullet pools, and we're going to say of type, right? If the bullet pools that I'm looking at, depending on the type we're in, 0 for enemy, 1 for player, 2 for whatever, less than 1, then add a bullet of that type, whatever the type is. And then it says temp bullet. We want to do the same thing. Bullet pools type, just that's a different way of looking at it. So like this, and we replace this by this. Just a different kind of code, right? Looks kind of a little bit more cryptic, right? But it's okay. Temp bullet, we get it from the queue, we dequeue it, transfer the position to the spawn position, set active, temp bullet, done. Okay, so that is a bit leaner. No more switch case, right? And same thing goes here, right? Where we say that, let's do the same thing, bullet pools, type dequeue, and we're going to unqueue it. And we don't need all of this, because we can get rid of this and put this like this. And we've got rid of all that, right? So that is the new stuff. And it's a lot better than what it was if it worked, but it won't because we still need to do this. And so my recommendation is inside of the, going back to the code, let's bring that up again. So we've tried to modify this a little bit, and let's go back in this, and let's see how this is going to work for you. And then we'll stop after this. And these are pretty good optimizations. There's more. We can keep going, right? But I think these two are pretty good. Or these three, I would say. All right, so we've blah, 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 whatever. What we need is inside of our scripts, and inside of our enumeration for bullets, we have BulletType. And right now we have enemy and player, but we can say number of bullet types. And I know it's really ugly, but this is great because what it does is we can use number of bullet types as 2, which is what we need for our script to detect. Instead of us detecting how many of those enums we have, we can use that hack, this hack, like we've done in the past. This is not new. So if I go back to, again, our BulletManager, and where we have the to-do, we can say that, okay, so for I want to for a for loop to the number of bullet types. So we're going to say bullet type dot number of bullet types. We can convert this to int. Woof, right? And that is how many collections we need. Create a number of collections, Q collections, based on the number of bullet types. That's what we want to do. So here we would say is bullet pools I is equal to a new queue of type game object. Right? And if we don't do this, then we won't have the collection created. The container will be empty, or the container will be pointing to null, and we won't be able to add anything to the container. And this will do it. If you don't like I as a subscript, I don't, then you can refactor, rename to count, which I like better. So, so if for count is 0, where count is less than the bullet number of types, then count plus plus, bullet pools count, which now that when you look at this, it speaks to you, bullet pool, the count, the number of bullet pools is equal to a new game object. So whatever that is. And that makes sense more. Now let's see if this bloody thing works or if we just killed ourselves because we deleted all that stuff. But the idea is good, Herman. I really like it. Let's see if this works. Maybe it worked for you. It might work for me. And run. And error. Okay, argument out of range, index out of range. And what did we say here? Y number of types 0, 1, 2, 0, 8, and 0 and 1. What is the number? What is the argument out of range? Name is index, but where? It must be there. Must be non-negative and less than size. Index out of range must be non-negative and less than size. So what does that mean? Tells you so this is the constructor and this is the initialize. Initialize is called, and so it's in BulletManager for sure. But where? Well, where? It's here. So it says that we want to initialize a new object of type count, but we don't know how many we have. Why? What is this bullet number of types? No, this is how you would do it. Remember that the list is here. So this is the list. So the list is the outside container. The list of, I have a list of objects, right? And I have to, sorry, you're right. I have to add it to the list. So instead of this, I have to say bullet, and I want to bullet pools.add, bullet pools.add, sorry, you're right, bullet pools.add, because I want to add a pool, but no, but that is, I'm adding a game object of type pool. So maybe I could do that. New queue of game objects. Maybe that's what you mean. Yeah, because it's a list, not an array. Correct. And let's see if that fixes it. Yeah. And play. I just want to see that bullet coming down. Want to see that bullet coming down? We're good. Yay! Awesome. Good job. So that gives me the ability to do the same thing, and we shouldn't run out of bullets. But now the great thing about this is that we've just cut down a whole pile of code from our BulletManager, which is way more efficient thanks to Herman. Right? So we got to give him lots of credit here. But this was a bit of syntax that you have to work through. So, just to say, it's not as clear. Okay, I'm going to be honest and say that, right? Like when you look at a public list of queue game object bullet pools, right? Once you see this, you're like, what? Could you do this in an array? Absolutely. But the great thing about doing it in a list is you have all these really cool methods, and list methods are just more powerful in many ways. So future fit for this, I recommend using it a list and not not an array, because arrays are limited in what they can do. Okay. But this is really good because once we've added them, then I can loop through them for each list. I can do a for each loop. And this just gives me the number of types. So this is the number of types. Number of types is our hack. So it goes from 0 to 2 and basically creates as many pools as I need, right? Depending on the number of we have in our bullet type. All right, so that's pretty cool. Yay. Yeah, and I think that's pretty good. We've cut down a lot already. SwitchCase stuff is cut down. The only place where now we have some SwitchCase stuff is in BulletBehavior. We don't really have anything in there. And again, once I see SwitchCase, I'm always like, I don't like that. And the great thing about player behavior and enemy behavior is it doesn't really know what's inside. We just pass in, hey, I want a bullet. That's what I want. I want a bullet of type player bullet. I want a bullet at where do I want it? At bullet spawn position. Okay. My enemy bullet doesn't really know. It just says, hey, look, you know what? I want a bullet of type enemy, because by default, if I just put get bullet, it gives me an enemy type, right? So pretty cool stuff. So these two are great examples of using a factory. The factory is a singleton, so it doesn't have duplication. The only switch case now is in the factory, which makes sense because we're going to do an if statement of some kind just to be able to detect it. Do I have to use the factory? Not if, and this is where I can replace it, if I use the factory as a generic, or if I use the BulletFactory as a superclass, an abstract singleton. That doesn't really make sense, but an abstract class for the two singletons. I'd make two singletons, one of them for the one bullet or one type of bullet and the other one the other type of bullet. But here, I think this might be a cleaner implementation. All right. All right, so let's save all. And just one more run type. I want to make sure that we're good and all the scripts have been saved. And now we've got some much more efficient code, well, leaner code. We'll see how efficient it is when we do our optimization check later on. So now we can see how that works. And I think we're going to see that we're going to get bullet firing. There we go. All right, that's it for me for today. File, save project. I hope that was interesting to you as it was interesting to me. Any questions for the people that are still here? Would you do things differently? How about that? Or would you change something that I added? Like, would you make it an array instead of a list? What are your thoughts? Herman says he used an array instead. Yeah, it's fine. Array is okay, right? You're instantiating it anyway. I mean, it's immutable. The size of the array is immutable anyway. So, I mean, at the end of the day, you can use an array. But maybe in the future, I might want to do something with the bullet pools that are different than what I'm doing right now, right? This also works for things like monster spawners or all that kind of stuff. It's very similar, right? So The one thing we kept is the bullet type, and this is one thing that we could theoretically change. We can make it so that there's a bullet interface. So again, going back to the whole prefab idea, right? We have two bullets, enemy bullet and player bullet. They're both using enemy behavior or bullet behavior. And what we could do for the bullet behavior, this is something else we could do, is bullet behavior itself could be the superclass, the abstract superclass, right? And then what we can do is we could instantiate, or we can inherit from bullet behavior and create enemy behavior or enemy bullet behavior or player bullet behavior with some other things. One thing we're missing, and this is something that would make the enemy bullet behavior and player bullet behavior more reasonable. And let me show you what the interface might look like before we go. I'll name it something different just for us. We'll call it bullet. Okay, just to show you what it looks like. So we'll call this bullet. And we won't use it right now, but I'm putting it in here just to be descriptive, right? So again, instead of MonoBehavior, we'll leave it as MonoBehavior actually, but we'll make this the class instead of a class. What if I made the class, if you think about it, right? If I said that the bullet itself, actually we'll say we won't make it a bullet, we'll do this here. And we'll say that it's a public interface that's called bullet. And then what we're going to do here is these things, we'll call it, damage, which will be returning some amount of damage, right? Maybe an integer. And maybe something like do damage or deal damage, right? So the bullet deals damage. We can call it a payload, a lot of stuff. But this is the only thing that I could foresee that would be unique, right? So in this case, if I was to do that, and if I put it inside of the, so in bullet behavior itself, right? Let's make two more behaviors. I won't attach them, but let's suppose we did it, right? So we'll make two more behaviors. So bullet itself, it kind of deals damage, right? The bullet deals damage in some way, right? So let's just make a new C# script. We'll call this enemy bullet behavior. And let's suppose enemy bullet behavior inherits from bullet behavior. So there's bullet behavior. So these still work. And also implements bullet, right? And then it says, the reason why this is red now, it says, hey, you do not, implement the missing members. And what we need to do is we need to kind of deal damage. This deal damage is different for enemy bullet behavior compared to the other bullet behaviors. So let me just put this in here and say, instead of throwing an exception, what we're going to do is return an amount of damage. Let's say, for example, the enemy bullet does 10. And let's suppose, and this is pretty cheap too, let's suppose that the player bullet does 15. So we do a little bit more damage. So let's say create a C# script. We'll call this player bullet behavior. And then player bullet behavior also inherits from bullet behavior. Right? And we don't have any of these, but we do have, it's going to also implement the BulletType interface, right? Where we can say that it deals damage and it returns 15. So 15 damage every time it deals damage. Okay. So what? Well, because that is unique, right? And maybe there's other things that are unique to bullet behavior, player bullet behavior. Like, for example, the direction, right? That might be a difference. in player bullet behavior. So notice that I have, can I access my bullet direction? Well, the answer is bullet direction, which is a vector, right? If you look at the bullet behavior superclass, and this is the bullet behavior superclass, then a couple things here for bullet behavior. We have bullet bounds and bullet velocity. Both of these are public, so I should be able to access them in player bullet behavior. So if I type in bullet velocity, and let's do it something like, so notice that it says that if I said something like bullet velocity here, but I have some kind of initialize function. And the initialize function, I recommend, you can also put it in start, because it is its own subclass, right? So I could say that start also calls, I could say that bullet velocity, right, is equal to a new vector 3, and I can put in the bullet velocity here, as opposed to what I've done inside of bullet behavior here, right? So here I put my bullet velocity, I entered it, I let the player enter it in, right? But what I'm saying instead is that, hey, you know what? I'm going to set the bullet velocity myself. Let's say that's going to be something that's different. I could also make it public. I could also have this piece, right? So I can say, well, you know what? The bullet bounds and bullet velocity are going to be different. And here's something. Can I redefine them, right? Bullet type is also something that we would consider, right? So let's go back to player behavior, right? Can I do that? Can I rejig? Because it's still something. Can I still do this? And it says, well, yeah, the keyword new is required on bullet velocity because it hides field vector 3 bullet velocity, bullet behavior, bullet velocity. So that's something that it's telling me. Same thing with bullet bounds, right? And this is where that is going to be here. I'm just decoupling those things. So if I say something like, well, my bullet velocity for my player bullet is going to be up, so it's 0.0f and kind of 0.1f and 0.0f, right? That's this. And then my bullet bounds, maybe I won't change those. Maybe I'll leave them as is. I like them, right? So that's the only thing that I've changed in the start function, right? And then I deal this kind of damage, right? Because all bullets deal damage. So I can do the same thing with my enemy bullet behavior, where I kind of add that in. And we can say that that is negative. So we're actually specifying where that's going to be specifically for these bullets. The other thing we can also say is in bullet behavior, we said that it's a public type. Public bullet behavior type is type. We can also specify that what that is. So we can say that the type starts off as something where type is equal to bullet type player. So we're specifying that type, we're configuring, if you will. And the same thing goes with this. Just to save some time. So this is something else we can start doing. We can start thinking about using those two things. And now that we have this, right, we have a different change compared to different types of bullets based on the type. So player bullet behavior and enemy bullet behavior could be attached to the two prefabs as opposed to the bullet behavior superclass, where this is exactly the same. And then maybe you want to think about overriding the CheckBounds function, right? So public void. You want to kind of, you may override. I put the virtual keyword in there. What that allows me to do is I need to make it public. Yeah. Or protected. That might be good. Private protected. Private protected? No. Protected virtual void. So protected is a great word because in this case, this is the one time I might want to do it. I might say that, hey, you know what? If I inherit from BulletBehavior, then I could change my CheckBounds function if I want to here, right? So I don't have to, but if I want to, I can implement my CheckBounds here. So I can say something like, members protected. So I can make public CheckBounds. If I start typing about, it's kind of thinking about overriding my methods, right? I want to override the method that is built in. So it says, I may want to, I want to override that thing, right? So this is this piece here, BulletBehavior. Virtual, so what virtual does is it allows me to, I may override instead of must override. By the way, if I save all, I haven't attached anything. It doesn't break anything if I do that stuff when I made those two classes, enemy BulletBehavior and player BulletBehavior. But if I want to make changes, then this is where those changes have to be. Instead of BulletBehavior here, and let me just show you what that looks like. So if I go to scripts, and if I take, in the bullet folder, if I go to, this one here is the enemy bullet. If I take enemy BulletBehavior, let's attach it and see what it looks like. Then, well, you can see that the type automatically is enemy, and it kind of has that type in there twice, type, right? And bullet bounds, that's something that we don't inherit. So notice that even though it's here, 5 and minus 5.5, unless I define this piece somewhere else, that's something that needs to be fixed here. But this is interesting, that we're getting it twice. And we're getting it twice because we get it once from here, and we get it once from here. Okay, so we're redefining what that type is inside of the behavior, right? So instead of pulling it down, we're actually kind of showing what that is. So in other words, we're defining it once, and then we're defining it again here, right? So we wouldn't have to do this. We can just basically do one of these because we have access. We can say bullet velocity because it's public is equal to this. And the same thing goes with our enemy behavior. We don't have to specify the type. We can just kind of do one of these, right? And that should take away some of our errors, like so. So there's enemy bullet behavior where we have our enemy type, but we need to specify our min max values. So you can see we have a lot here that we already get by default, right? And our min max values are something that we can set. So 5.5 and negative 5.5. I know I'm over, guys. I'm so sorry. But I wanted to talk about this. So let's just do it for just the enemy bullet behavior first, right? So we'll just remove this script. Actually, we will just dim it out. How about that? So we'll just say this script is not attached. Okay, let's run it. Let's see if that works or if it's got an error, right? So still good, right? So that's pretty good, right? So that we can specify the type, and we also know that it deals damage. So we can access the deal damage method whenever we want to. So we say that bullet type, whatever that is, that bullet, it can deal damage with that bullet, right? Compared to what I have. So it carries a payload compared to what it did before. So again, we can get rid of this. And then same thing with our player bullet prefab, where we have to keep these things, these bullet bounds, but if we take our scripts, our player bullet behavior script and attach it, and then just set up these values like we normally would, then we should be able to do everything that we did before by pressing the button. Now that's interesting. Oh, that's awesome. Look at that. Woo! Something's wrong there. And most likely it's the fact that all player bullets start off as enemy, but we'd have to make them as player. Let's see if that's true. Let's see if that's the reason. So you mess things up, eh? Yep. Somewhere we mess things up, but that's okay. That's minor fixes. It's accessing both pools. Yeah, and the type is important. So if we don't set up the type, did I make a mistake in the player? BulletType is player. Oh, that's why. That's type is enemy. There we go. That's the reason. Type is player. And then, of course, going to go to the wrong pool. All right, and let's try that again one more time. Yep, now we're good. And we can then make our bullet behavior abstract. And if we do this, public abstract class, then that should affect the ability for us to instantiate that type. So we can make a bullet class, but now it's of type bullet behavior. And now that we've done that, we can identify each of these types of bullets in the BulletFactory. So instead of BulletType enemy, BulletType player, right? When we create a bullet, we don't need to do this anymore. We don't have to pass in the type of bullet we want to instantiate, because at the end of the day, what we can do is we can say what type of this is. So if I look at whatever the type is, that's the type that I want. And so we can say that the type that I want in here in my create bullet is of type bullet, right? We can say bullet, right? And the reason why we can do this bullet is because all bullets are of type bullet. They all have the interface, right? Whether it's an enemy bullet or a player bullet. And what we want to do is when we're down in here, we can say that the type of bullet, let's suppose var type, we'll call bullet type, just to give you the test, is equal to the bullet, but I want the type of. So if I go type of, and then I go bullet, right? Whatever that type of bullet is. So I want, depending on what it is, I can say if bullet type of any bullet behavior, then, so I don't have to do a switch case. I mean, I can do a switch case, but instead of type, like this whole enemy type thing, I can swap it out with the bullet itself. So I can get a reference to the whole bullet that I'm getting, that I want, as opposed to the other type. I want this type of bullet. But let's not do this. And the other thing is I could make a new BulletFactory, right? So BulletFactory, remember we said that BulletFactory could be abstract. And I can instantiate a new object of type enemy BulletFactory or player BulletFactory. So I can split these up. And for the most part, it would be the same amount of code, except that we would have an extra layer. So I'm not sure that I would do that in this case. I think it might be better in Unity this way. All right, questions around this stuff, this craziness that I've kind of put up. So again, the only changes I made were enemy bullet behavior and player bullet behavior. They are bullet behavior types. That's all they are. But the difference is that we have very little code in each one of these things. Only have this, but yet everything else works. And the reason why everything else works is because it inherits from type BulletBehavior, and BulletBehavior already has stuff. We override our start function, where we add our kind of types that we want in here. And then we have a special function that all bullets have, which is deal damage. And we can have other ones, make sounds or whatever. Each time a bullet makes, you'll have different kind of sounds depending on the bullet type, and we can make it based on the prefab prototype. All right, that's it, guys. Way over what I wanted to do today. Hopefully that helps some of you with thinking, and that's it. Let's shut this down. Good. And if you can see where you can use interfaces now, they're great for identification and so on as well. Interfaces are a great way of making you, kind of creating a structure for your code that other people would use. If you're the senior software engineer on your team, what you want to do is create some interfaces that people would have to use and override. They must override those functions. They must define them in order for them to use them. All right, let's put this up on GitHub. So file, save project, and let's exit. And let's put this up on GitHub. So again, view changes. I'll say added bullet interface and related classes. We'll say subclasses. Okay, and push. That's way more than I wanted to do today, but hey, we're good to go. All right, any other questions before we go for the day? Again, we went way over, but I thought that would be a little bit of enrichment in terms of some optimizations, and there's many more we can do that we haven't touched yet. Just as a recap, again, for those people who are still here, please make sure that you remember that next week, assignment 1, part 2 is due at the end of the week. We're also starting off with week 7. And one thing to note is that I still will be covering touch input, presses, and gestures next week, because again, it'll be a bit of a review of what I want you guys to do for your exam, your midterm test. But your midterm test will, again, start from the beginning of the week and the end of the week, and you'll be giving a small assignment to do that's going to be due. Okay? Questions? Guys, thank you so much then. I think we've killed this one to death for this week, and I'm hoping to see you guys next week. Good luck on your assignments in your lab.